Dear friends, in this class, let us discuss more on the aircraft performance. So, in this class, let us discuss on the climbing flight. So, climbing flight, we all know that. Okay, so before reaching the steady level flight, anyway, it has to undergo the climbing. So, without climbing, the aircraft cannot reach the steady level flight. So, because in the flight region, if you see initially it will be in taxiing, so it will be in taxiing, and then after that it will go for takeoff, then it will go for the climbing, then after reaching, okay, after the climbing, then only it will go to the cruise or we just say steady level flight. Okay, so this in this region the climbing is okay, very important. So okay, before that, okay, it undergoes the takeoff as well as, okay, taxiing. So what we can say, the cruise flight or steady level flight, that will be equal to the horizon, that means earth. Okay, so our surface. So this is if this is a steady level flight, then this flight and this condition both will be in parallel. Okay, so before reaching the steady level flight, so it needs to undergo the climbing. So how it is happening, so well, let's see. So yeah, so the climbing flight, okay, so we have just drawn the diagram. So this explains how the forces will be acting in the climbing flight. So flight is, okay, flying with or climbing with the velocity v. Just we can say that it has the velocity v. So it has the okay, it has the velocity v, and okay, so the lift, weight, drag and thrust. Okay, so because generally the lift will be acting perpendicular to the flight path. Okay, so that is what okay, it is acting. And then here, okay, since it is in the climbing condition, it is in the inclined condition, so this we can say this angle between the horizontal and flight path, so that is nothing but theta, so that is what we say angle of climb. Then okay, now because of this climbing position, what happened, now the weight is acting vertically downward. Okay, downward to the okay, downward, that is because of the center of gravity. So so that, okay, makes an angle theta. This theta and this theta both will be same. Okay, so now weight is acting vertically downward in the inclined flight. So now, and then as we know, drag, as usual, it is acting okay, this perpendicular, that means backside of the aircraft, and then forward of the motion, thrust is, okay, acting. Generally in many cases, what will happen, the thrust line and flight path, okay, the flight path, both of them will not coincide. So that thrust line will have some small angle. So that small angle, for simplicity purpose, okay, we have removed that small angle. So yeah, generally when we write the equation of motion, that small, okay, deviation will be considered. Deviation will be considered. That is that is why the thrust line and the flight path line both will not be in the same position. Okay, now let us write the equation. Now, okay, along the flight path, okay, forces along the flight path. So what are the forces along the flight path? Okay, so first let us see the forces acting. So here we can write this is we are resolving, okay, we are resolving the forces along the flight path. So that is thrust, okay, then minus this, okay, this one side is thrust, other side, okay, we are taking, that's why negative. So drag is there, minus, then this w also is there, w also will be taken to this side only. So just if you are putting this, we can put a plus, then w, So this is okay. If it is coming into the vertical position, it will be cos theta. So now it goes to the horizontal, that one, so it is sin theta. So this is sin theta. Then that is equal to summation of forces. Okay, we are resolving the forces. Okay, so that will be equal to the summation of forces. Summation of forces generally in the we can represent by using the Newton's second law of motion. If you are writing Newton's by if you are considering the Newton's second law of motion, the summation of forces will be taken. That means we can just say that m in mass into acceleration. So m into dv by dt. Okay, so it is acting along the flight path, so velocity okay is acting, so the acceleration nothing but dv by dt. So this is what generally we say summation of forces, summation of forces. Okay, so now because of this, okay, this is we are resolving the forces along the flight path. Then for that we got this equation. Then perpendicular to the flight path, if you are resolving the forces perpendicular to the flight path, perpendicular to the flight path, how it would be perpendicular to the flight path. So that is we can write as the this one. So means lift equal to perpendicular to the flight path, nothing but lift equal to w cos theta, w cos theta. So here also the second law of motion can be applied, because that is this is equal to summation of forces. Okay, that is we can just say L minus W equal to this is mass into here. Okay, generally centrifugal acceleration will be taken into account, so that we can write d theta by dt. So v into d theta by dt, nothing but centrifugal acceleration. So this is what, okay, summation of forces in the case of, that means perpendicular to the flight path. So this is we can write in some books, or in some cases we can write this is equal to v square by rc, because this is radius of the centrifugal radius. Okay, so okay, so this is what the equations for the this climbing flight. Okay, so now let us find the rate of climb. How to define the rate of climb? So when we are defining the rate of climb, so that is generally we just say this velocity component. The velocity component will be resolved, okay, into two components. That means if you have the velocity components, this velocity component, this is the what we can say resultant. So this resultant velocity component will be resolved into vertical and horizontal. So when you are, okay, resolving this is we can just say v infinitive. So then this is nothing but vertical velocity, then this is horizontal velocity. Okay, so this is nothing but theta. Okay, so from this we can just say this vertical velocity, that is nothing but we can write this vertical velocity, it's equal to v infinitive, this is okay, this is nothing but v infinity into sin theta, whereas this is okay, we can write it as the v infinity into cos theta. Okay, so as per the definition, the rate of climb is defined, this is vertical velocity, this is what, okay, rate of climb is defined v infinity into sin theta. It means now our rate of climb becomes rate of climb, this is what rate of climb. So rate of climb, okay, as per the definition, nothing but this vertical velocity, so v infinitive sin theta. Okay, so this is okay. Now because this equation we have taken and we have just the summation of the forces according to the Newton's second law of motion, that also we have written. So when we are considering this one, what happened in the case of steady level flight or steady unaccelerated flight, so this term will be 0. Okay, in both this term will be 0. Similarly here also this term will be 0. So steady unaccelerated flight these two okay terms will not be there. So only we will have this rest of the term will be there. That means the rest of the equation becomes t minus d sin theta equal to 0. So this is one of the equation. Then this is okay, we can say equation 1. Then another equation we can write yeah, second equation we can write this one, lift equal to w cos theta. So this is equation number 1, this is equation number 2. So these two are the equations going to play the major role okay, how the climbing flight performance is going to be analyzed. So by keeping this equation we also can find out the angle, okay, angle theta we can find out. So from equation 1 we can write this one. So theta can be found out from equation 1 we can find the theta, that is sin theta equal to t minus d divided by w. Okay, so this is one thing. So theta we got it. Then but rate of climb is nothing but we just say this rate of climb is nothing but v infinity into sin theta. This is what rate of climb. So this is, we say RC, or okay, so we can write RC rate of climb, that is equal to we are writing v infinity into t minus d divided by w. Okay, so from this what we can understand how the better climbing can be achieved. Okay, because even from this equation or this equation we can just see the equation, if the thrust is higher, if the thrust is thrust required is higher, then we can have the higher rate of climb. If this is higher, then we can have the higher rate of climb. Then if the drag is lower, okay, so if the drag is lower, then also we can have the best rate of climb. Or if the weight also, okay, weight also if it is lower, because if the weight also if it is lower, then we can obtain the best rate of climb. So that is what this equation says. Because in the steady unaccelerated climbing, what happens, this velocity will be constant. So this velocity cannot be changing. Okay, so velocity will not change. Because of that reason, okay, so the rate of climb will not have any influence based on this v infinity. So only this component can play the role. Okay, so if you are multiplying this parameters t into this one v infinity minus drag into v infinity whole divided by w. So this we say power available, this is nothing but power available minus power required. So that means thrust, based on the amount of thrust, based on the thrust available, that is what, okay, we say power available. Okay, so our, okay, we just say this from this rate of climb, okay, equal to, this is nothing but power available minus this okay, drag. To overcome the drag, how much power is required, so that is power required. So power available minus power required whole divided by w. Okay, so this is, in this way also, one way we have, first we have seen how to define the rate of climb. So we can define in this way. In another way we are defining based on the power available minus power required. Generally this is called excess power. Okay, we can just say it is nothing but excess power, so by w. So based on the excess power, we can just define the climb performance. So if the excess power is higher, so if the excess power is higher, then rate of climb also will be higher. Or excess power is that means maximum, then maximum rate of climb can be achieved. Or if you say weight, if the weight is okay lower, then in that case also we can have the better rate of climb. Okay, so I think how we are just defining the rate of climb based on okay this triangle, this vectorial triangle, then how we are okay bringing the rate of climb and linking with the power. So based on the power available and the power required, so how we define the okay, based on that how we define the rate of climb. So that also I think, I hope it will be clear. Then this vertical velocity versus horizontal velocity, later on this also we are going to okay discuss separately. So that is what we used to call it as hodograph. So later we will discuss, we will see more about climbing performance in the